Let's try problem 9.15. A 2.7 kilogram block of wood sits on a table. A 3-gram bullet, fired horizontally at a speed of 500 meters per second, goes completely through the block, emerging at a speed of 220 meters per second. What is the speed of the block immediately after the bullet hits? Okay, so the first thing is always just to draw a picture. So we have a bullet. Let's say that's a bullet. And it's traveling at 500 meters per second. And it has a mass of 3 grams. So let's just go ahead and convert that. So that's going to be 0.003 kilograms, right? So I want to make sure I'm on the same units. So I have grams here and kilograms here. So I'm just going to go ahead and convert them all. And then we also have a block that's just sitting there. And it has a mass of 2.7 kilograms. Okay, so that's the first part. In the second part, we have that same block of 2.7 kilograms, but it's now moving at some velocity. Call it velocity sub c for velocity of the cube, and that's what we're trying to figure out, right? What is the speed of the block immediately after the bullet exits? Okay, so then we're given and then we have a bullet emerging on the other side, and we're told that that speed is equal to 220 meters per second. And it still has a mass of 0.003 kilograms. Okay, so now all this is a conservation momentum problem, right? We have the bullet, which is going to give so much momentum to the block, and it's going to cause the block to start moving. And so we know that the sum of all the velocities initially have to be equal to the velocity. I mean, the momentums initially have to be equal to the momentums final. And so this just becomes, right, the mass of the cube times the velocity of the cube initial plus the mass of the bullet, m sub b, times the velocity of the bullet initial. And so all this is just the first part, right? We got the mass of the cube times the velocity of the cube initial, and so you'll notice that this block isn't moving, so this whole term right here just goes away. And then we have the mass of the block, the mass of the bullet times the velocity of the bullet initial. And so we're given those. And so we know that all these momentums over here have to equal all these momentums over here because it's a closed system. And so this is going to be equal to the mass of the cube times the velocity of the cube final plus the mass of the bullet times the velocity of the bullet final. Okay, so what we're trying to figure out is the velocity of the cube final. And so we know everything else, right? We know the mass of the bullet, we know the velocity of the bullet initially, and we know the mass of the cube. We don't know this, what we're trying to find out. We know the mass of the bullet, and we know the velocity of the bullet final. So all we have to do right now is just rearrange. So I'm going to subtract the mass of the bullet times the velocity bullet final from both sides. So we're left with m sub b times v sub bi minus mass of the bullet times the velocity of the bullet final. And this is going to be equal to mass of the cube times the velocity of the cube final. So then we just divide both sides by the mass of the cube. So that becomes 1, and this is over the mass of the cube. And so this is our answer right here, the mass of the bullet times all this stuff. And so velocity of the cube final, when you plug all this into your calculator, becomes 0.31 meters per second. And that's problem 9.15.